வந்த உடனே okay, I am Dr. Babu, Department of Biomedical Engineering, Professor and Head. Today I am going to explain about the surgical diathermy, that is introduction to surgical diathermy. So before that, okay, diathermy means, dia means through, thermy means temperature. Through temperature, we are treating through temperature, it is called diathermy. In that diathermy, we are using high frequency only, we are not using the low frequency. Low frequency current, generally it stimulates the nerves and muscles, and high frequency current, it will not stimulate the nerves and the muscles, so that we are using the high frequency. So first of all, before going for the diathermy, you have to know, in diathermy we are using only the high frequency current, we are not using the low frequency current. The first title we are explaining about why we are using the high frequency currents, whether it is safe or not. Okay, the current we are using in diathermy is equal to 1 to 3 megahertz. It is a high frequency. So how much it is high, that we can compare with the frequency of current which is we are using in our domestic applications. In our house, the frequency what we are using is only 50 Hz only, but in diathermy we are using the 1 to 3 megahertz. The minimum is equal to 1 and maximum is equal to 3 megahertz generally. Now it is megahertz, mega is equal to 10 to the power 6. Okay, now you can easily compare the 50 Hz main frequency and in terms of megahertz. Okay, this high frequency avoids the intense muscle activity and the electrocution hazards which occur if low frequencies are employed. Okay, so simply we can say it is not stimulate the muscles and nerves, and the low frequency it will stimulate the muscles and nerves. So that's why we are using the high frequency. Next point, the power level required for the electrosurgery are below the threshold of neural stimulation. Okay, below the threshold of the neural stimulation, to avoid the stimulation of the nerve unnecessarily, provided that the diathermy frequency is in the radio frequency range. Okay, so we have to select the radio frequency range for diathermy, and the power is equal to, the power level is equal to below the threshold level, so that the nerve stimulation can be avoided. Frequency wise also high frequency, and the power level also low power below the threshold value, to avoid the stimulation of the nerve. So that's why we are using the high frequency and also low power, that is a low power means below the threshold value. Okay, when the frequency is at least 300 kilohertz, not only high frequency, the minimum level, if we use the 300 kilohertz, both Faraday and the electrolytic effects are largely eliminated during the flow of current through the human tissue. Okay, so 300 kilohertz, the minimum frequency is equal to 300 kilohertz, below that we are not using. Okay, if we are using 300 kilohertz, the Faraday effect and the electrolytic effects are largely eliminated when we are using the human tissue. This allows the exclusive utilization of the thermal effect in high frequency surgery, providing both the applications for cutting and coagulation. So in the diathermy we are using cutting, coagulation, fulguration, desiccation, like that we are having different kinds of techniques we are using. So in this case, the cutting and the coagulation, particularly we are saying in cutting and coagulation, okay, the utilization of the thermal effect in high frequency surgery, providing both the cutting and the coagulation. So this is that's why we are using the high frequency current. So the high frequency current is very safe in the diathermy. Okay, next slide we can go for what are the types of electrosurgery techniques in the diathermy. Okay, already I told you about the diathermy. Dia means through, thermy means temperature. Okay, the temperature can be created by using the electrical energy, chemical energy, mechanical energy, like that, any kinds of energy. Okay, so that's why it is diathermy. Okay, types of electrosurgery technique. What are the different types of the electrosurgery technique? You can see in the screen. The first one is cutting. Cutting is equal to one technique. It is also called electrotomy. Cutting, coagulation, fulguration, desiccation, and homeostasis. Homeostasis mode of operation. So these are the some of the electrosurgery technique. We can see one by one. We can see one by one after that. Before that, we can go for the principles of surgical diathermy. Okay, this diagram explains about the simply what is the principles of surgical diathermy. Okay, this is a diathermy equipment. This is a diathermy equipment which produces the high frequency current. This high frequency current, we are having positive and negative port. Okay, terminal. From the positive terminal, the wire is connected to the electrode. This electrode is connected to the needle electrode. Okay, so this is active electrode, or it is called the needle electrode. Needle will be connected for cutting. So as I already told you, cutting, coagulation, desiccation, different kinds of electrodes are used. For example, if we are using the cutting electrode, we can use the cutting electrode, or coagulation, we can use the coagulation electrode. So from the positive terminal, the wire is connected to the, it is a hand button. In the hand button, we are connecting the cutting electrode, that is needle electrode. Okay, here you can see the patient table. The patient is lay on the patient table. Below that, we are using the indifferent electrode, a large area indifferent electrode. What is the function of the indifferent electrode? It simply collects the current. It is applied to the human being. This current again from the indifferent electrode, it goes to the surgical diathermy equipment to the negative terminal, so that the circuit is closed. Whenever the circuit is closed, then only the current will be supplied to the human being, otherwise it is disconnected. So here from the positive terminal of the equipment, current goes to the finger push button. The end of the finger push button, we are connecting the needle electrode. From the needle electrode, because of the current, the needle point is equal to getting heated, so that because of that, what happens, the tissue can be easily evaporated in the point of contact, so that surgery will be very, very easy. Without giving any force, we can easily cut the tissue. Okay, it may be tissue or coagulation. Okay, the current coming to the body, it should be collected, it is be returned to the equipment. So that's why we are placing here a very large plate. It is called indifferent electrode below the equipment. The function of the indifferent electrode is to collect the current, and the area of the indifferent electrode, or it is also called the patient plate. The area of the patient plate is large, so that it is not getting heated, it is not giving any surgery operations to the tissue. Okay, that's why we are using the large area. Current density will be decreases because of the large area. Okay, then it is collected the current and it is given to the equipment. So this is the principle of the surgical diathermy. Very simple. From the positive terminal, needle is connected. The needle, current coming from the needle flow through the body. It collect, all the current will be collected to the indifferent electrode, then it returns to the equipment. The circuit is completely closed. Right side you can see the electrode, needle electrode. Below that you can see a diagram of the surgical diathermy machine, electrode, and how it is connected. So how we can increase in the intensity, and we can decrease the intensity of the current. Okay, one is for cutting, the knob is only for cutting, another one is for coagulation. So this is the surgical diathermy machine. Okay, visualize the explanation. Okay, next the principle of surgical diathermy. What I have explained in the diagram, the same thing is explained here as a words. Okay, so the high frequency current, the current we are using is equal to 1 to 3 megahertz, can be used in the operating rooms for surgical purposes involving cutting and coagulation. Okay, surgical diathermy machines depends on the heating effect of the electrical current. So the electric current applied to the needle will be getting heated, so that surgery will be very very easy. There is no force applied, there is no need of force applied. When high frequency current flows through the sharp edge of a loop or band loop or the point of a needle into the tissue, so that is given as explained in the figure, there is a high concentration of the current at this point, because needle, okay, all the current is concentrated at the point of needle. So that is okay, that's why the concentration of current is applied to the needle point. Okay, the tissue is heated to such an extent that cells which are immediately under the electrode are torn apart by the boiling of the cellular fluid. Okay, that's why the surgical operation takes place. The indifferent electrode, already I told you as a patient electrode, the indifferent electrode establishes a large area contact with the patient, and the RF current is therefore dispersed so that very little heat is developed at the electrode. Okay, this is a large area, and the heating effect, only very very less heating effect takes place, but it is not doing any cutting or coagulating function. Okay, because of the large area. Okay, this is the principle of surgical diathermy. Now we can see one by one what is cutting. So diagram you can see, it is the pointer that is operated by hand. There is a switch. End of the pointer is equal to, we are having needle. The needle is touches the tissue, so that the tissue fluid will be boiled and tissue can be turned out. Okay, a combination of fine wire electrode, high RF voltage and high cutting speeds are necessary for confinement of tissue destruction in electrosurgery. Okay, these parameters are of great value in microsurgery, since localization of the electrosurgical effects would be accompanied by coagulation and hemostasis. Evolving steam bubbles, because of the heat tissue fluid will be boiled, so evolving steam bubbles in the tissues at the surgical tip continuously rupture the tissue and are responsible for the cutting mechanism. So this is the cutting. Simply we can say, due to the current the needle will be getting heated, due to the heat the needle touches the tissue will be getting heated, tissue will be boiled. Because of that there is a rupture, it will rupture the tissue at the point of contact. This is called cutting. Okay, the same thing here we are using the coagulation. So coagulation is equal to, okay, melting the tissue at the point of contact to avoid the blood loss. We are not using the needle electrode, we are using the ball electrode for the coagulation. Only thing is, instead of the needle electrode, we are removing the needle electrode and we are inserting the ball electrode. Why it is called ball electrode? The end of the electrode is equal to a small ball will be there, so the heat is applied in the ball. Okay, that's why it is called ball electrode. So this ball electrode generally used for the coagulation. Electrosurgical coagulation of tissue is caused by the high frequency current flowing through the tissue and heating it locally so that it coagulates from inside. Okay, it will be converted as a clot like structure or clot. Okay, that's why it is called coagulates. From the inside the tissue will be coagulated. The coagulation process is accompanied by a greyish white discolorization of the tissue at the edge of the electrode. Okay, how we can find out the coagulation process takes place is equal to, the tissue color of the tissue will be changes to the greyish white discolorization. In contrast to the thermocutter, better coagulation can be achieved by high frequency currents because it does not cause superficial burning. Superficial burning is not caused. So that's why we are using the coagulation. Okay, next technique is fulguration. Fulguration is equal to superficial dissection of the tissue by applying the heat is called fulguration. Okay, the exact definition, the term fulguration refers to superficial tissue destruction without affecting deep-seated tissue. Okay, internally, okay, in deep from the surface, internally in the deep-seated tissue, it is not affecting, only the surface of the tissue will be destroyed. For example, skin, above the skin, superficial surface of the skin only destroyed, and below the skin the tissues will not be affected. So it is fulguration. This is undertaken by passing spark from the needle or a ball electrode of a small diameter to the tissue. Okay, so in that cases, okay, we are using needle electrode or ball electrode with small diameter. It is not touching the tissue, a small distance in millimeter distance, like that we are keeping the distance between the electrode point and the tissue. So that spray will be generated, spark will be generated. This spark will be applied to the only the tissue surface, that is surface of the tissue only. So the surface of the tissue only we are applying this spark, so the surface of the tissue only affected, not the deep-seated tissue. Okay, when the electrode is held near the tissue without touching it, an electric arc is produced whose heat dries out the tissue. Okay, whose heat dries out the tissue. Fulguration permits fistulas and residual cysts to be cauterized and minor hemorrhage to be stopped generally. So this is the fulguration. Okay, next one is desiccation. Desiccation is another technique. In desiccation, needle point electrode are stuck into the tissue and kept steadily for some time. Okay, a needle electrode we are using, that is stuck into the tissue and kept for some time. High frequency current is applied continuously within the tissue. Okay, so needle goes inside of the tissue. Depending upon the intensity and the duration of the current, a high local increase in the heat will be obtained. The tissue changes to a drying and limited coagulation. This is called desiccation. This diagram you can see, it is called desiccation. Okay, so this is the only one other technique. That's all we can see about the principles of surgical diathermy, or you can say introduction to surgical diathermy. Okay, up to this we can stop. Thank you.